Hello, Calc class. It's after Wednesday's class on the 15th, our last review session before the test. So I would like to remind you that you must find derivatives of inverse functions, derivatives of inverse trig functions, derivatives of log and exponential expressions, and also be able to do logarithmic differentiation. And the other thing on the list was integration. So that's a new topic for us. So there won't be a lot on integration, but there will be some. And our BFF, our best friend forever, is now the integral of x to the n dx, which we have learned is x to the n plus 1 over n plus 1 plus a constant c. So you're going to be asked to apply that, and also some trig integration. There will be no right and left box calculations. All right, let's do an example what there will be. You'll recall everything that we integrate should look like this other than trig functions. So we have to get this to follow this pattern. So we got to move the 15 out of the way. Constants may cross across the integration sign. Excuse me. So I have 15 integral x cubed dx, which is x to the 4th over 4, and the 15 will come along. So I'll write that a little clearer. 15x to the 4th over 4 plus c. All right, don't forget to crown it. Crown it with many crowns. What about this one? What about if there's a negative exponent? It will still follow this integration pattern. The 1/2 will cross the integral sign and leave us to apply our best friend forever. And it becomes the 1/2 and then x to the negative 2 plus 1 divided by that. So cleaning that up, we get 1, it's negative 1 over a 2x plus c. All right, let's go on and let's talk about integrals that might be on the test that involve trig functions. So there could be something like this. And the only way that could be on the test is if it is exactly one of the derivatives that we know. So kind of thinking backwards, what expression has this as its derivative, or almost this? Well, we know this is what's in our thoughts. We know when y equals cotangent of x, y prime equals negative cosecant squared x. So this is almost that. So the answer will be this expression only with the negative sign plus c. All right, so recognize that we will know in the trig, when we're doing integrals with trig functions, they will have to be just what we learned as derivatives, only backwards. So probably the simpler ones are the hardest because they are, like the integral of sine x dx, which you can memorize, or you can just try to think backwards. Like I'll say, oh, I'll just say it's the cosine. And then I check myself. Course, plus c. So I say y equals cosine of x, but y prime, I remember, is minus sine of x. So it didn't get me back. So I'm going to put in a negative here, and that will get me back to where I need to be. So if y equals negative cosine x, we know y prime is going to be negative sign, which is a positive sign. So sometimes the simpler ones are more confusing. And so what would be the integral? I don't know, secant tan That should just be by recognition. That is the integral. Secant tan is the derivative of what expression, and that will be the integral of this. Secant tan must be secant x. Let's see. What about integral of cosecant x cotangent x? Well, coming off of that one, you probably see that it's going to be related to cosecant. But that's not exactly right, because if y equals cosecant x, y prime, you'll recall, is negative cosecant x cotangent x. So we don't have the negative, so we need to put it in. There's no negative in this problem, so we need to put it in here. All right, so go ahead and study all those trig derivatives so that you'll be able to unwind them and do them backwards. All right, I will allow you to bring on an index card any derivatives of inverse trig functions. So you do not have to memorize those. But these for logs you do have to memorize. So if y equals ln of u, remember y prime is 1 over u du dx. But what happens when it's a log? Then we have 1 over ln of a u du dx. So recall that and how to use it. Y equals e to the u, y prime, I should have put y prime up here, equals e to the u du. And if y equals a to the u, oops, y prime is a to the u ln of a du dx. All right, so these are principles more than formulas, so I want you to know these by heart. This one comes up a lot in our lives. This one is close to it. It only adds this factor. This and this are the same, except it adds this factor. So go with it. All right, go study and make your index card so that it has the derivative of the inverse trig functions if you want. Okay. Enjoy your study time and concluding this section of Calc. See you tomorrow.